Right, this question is chosen because it goes through a familiar question on papers about standard deviation. And so some students investigated the effect of light intensity in the environment on the size of nettle leaves. They measured leaves on 60 plants in 2 sites. The results are summarised in the table. So you've got the site with the highest light intensity and the site with the lowest light intensity. They're measured in millimetres, the length of the longest leaf, the length of the shortest leaf, the mean length, the mean maximum width, and then the standard deviation of the lengths and the standard deviation of maximum width. Each leaf was to be measured, was selected in the following way. The top left-hand corner of a quadrat frame was placed at coordinates given by a random number table. The nettle plant nearest the centre of the quadrat was selected. The 6th leaf from the tip of the plant was selected. Explain the importance of the method of selecting the nettle plant. Have a go. In this first question, the examiner's report states that many candidates understood the importance of removing bias in the sampling, but most only referred specifically to the random placing of quadrats and made no mention of systematic sampling of the nettle plants within the quadrats. Too many candidates did not get beyond saying to make a fair test. Good candidates, however, wrote about the need to control as many variables as possible, and that plants at different heights could be different sizes simply because of age, or they could be subject to different shading effects. So what was the correct answer? They were looking for selecting the nettle plant, the random number table avoids bias in placing of the quadrat, and nearest the centre avoids bias in choosing the plant to measure. So one of the marks was for method avoids bias. Two. What was the importance, or explain the importance of measuring the 6th leaf? Have a go. Well, measuring the 6th leaf, it allows valid comparison, so not to introduce another variable. It reduces or it avoids the influence of growth or age, or it reduces or avoids the influence of light or shading. So it's just making it the same for each test. Now mark your answer. In this question, it says use the data about the length of the leaves in the 2 sites to explain why standard deviation is more useful than range as a measure of variation within a population. To be able to answer this question well, you need to know what is the difference between a range and a standard deviation. Well, the range gives an overall spread of data from the lowest to the highest of the data, so the smallest leaf to the biggest leaf. However, it can be influenced by anomalous results. So if you had one that was really high or really low, that would affect the range. Whereas standard deviation takes into account the variable data spread, so it's the spread around the mean, and can be used for statistical use, so inferences can be made. So in this data, the ranges are similar in both areas. It suggests that the variation within populations is similar, but the standard deviation is smaller in the area of high light intensity, which shows that the area of high light intensity is a more uniform population, because the smaller the standard deviation, the less of a deviation around the mean there is. Now mark your question. Answer. Two. What other statistic could be calculated from the standard deviation that would give an indication of how the mean leaf length might vary in other samples from the same population of nettles? The answer to this is standard error. The next question is asking the area of, well, it's informing you the area of a nettle leaf can be estimated using the formula area equals length times maximum width times 0.5. Calculate the ratio of the mean area of the leaves from the site with the low intensity to the mean area of the leaves from the type with the high light intensity. Show your working. So to answer this question, you need to go back to the table. You need to be able to work out the mean in the mean area in the low intensity and the mean area in the high intensity, and then work out the ratio between them. Of course, as always, make sure that you show your working out. So the area for the high light intensity is the mean length is 86 times the maximum width, which was 68, times 0.5, which is a half, will give you for that one. And so that's the high light intensity, and then the low light intensity will be 92 times 74 times 0.5. And high light intensity, it will be 2,924, and in the low intensity it's 3,404. And then to work out the ratio, you divide the low intensity by the high intensity. So 3,404 divided by 2,924, and that'll give you an answer of 1.16415, which if we do it to two decimal places is 1.16. And just for this last part of the video, I just want to remind you what standard deviation is. So it's a set of values, and it's a measure of the spread of values from the mean. The mean value is often shown as a plus or a minus the standard deviation, and it is calculated. So S equals the square root of the sum of x minus, and x is the measured value from the sample, so x minus x like that, which is the mean value, squared over n minus 1. So that's the standard deviation. So x equals the measured value that is the mean, and n equals the total number of values.